Hello. Today I'm recording this video lecture, and I hope you all had a great Thanksgiving. I'm going to go very quickly over lecture 21. We already did this in class, but I'll summarize the main points here. And then we'll go and work on a couple of examples. It's going to be a glulam column first example, and a glulam beam. And I rephrase that, we'll do the glulam beam first and then the glulam column. Okay, so we are talking about glulams, or just that's the short for structural glued laminated members, and you'll usually just say glulams, and it is very useful. It is not the same thing as sawn lumber. So when you had your 2x or 4x, that's what we call just sawn lumber. And glulam is what we're talking about now. And glulam members in general, they're just fabricated from lams or laminations. And they're 1 to 2 inch nominal thickness. And then they're end jointed, they're glued together to any size of length. And really that makes it very flexible for us to be able to use in many different applications. So glulam member sizes, these are defined in table 1C and 1D of the NDS supplement. And I already went through that before, so I won't go into too much detail here. But really what we're talking about is a bunch of 2x. For example, that's one board that you could go and get off Home Depot. And then you take a second board, for example, you lay it side by side, and you press all of these together. So in between, we have adhesives here. But we press all of these together to create our glulam. Okay. And so this representation here, depth and width, and how they're laid together, it's just in terms of how they're labeled. And so usually the widths are such that we have the x-axis is related to the strong and the y-axis related to the weak, but it's not always. So sometimes x is parallel to the lambs. So what I'm mentioning is the text that's here. And so it just, when we're looking at tables, we should be aware of what is x and what is y. We will see different reference values, just like before for sawn lumber. It does happen that for glulams, we may have different positive and negative bending capacities, but then we have compression perpendicular to grain, FC perp, the shear parallel to grain, elastic modulus, EX, EY. Okay. And so EX is only when we're doing deflection calculations, and EX min is what we use for stability calculations. All right. So reference values for these for glulams are given in tables 5A through 5D of the NDS supplement. 5A defines our stress classes, and stress classes have to do with the capacity, and often they'll also tell you what the Young's modulus is. So for example, a 16F is telling us that our reference bending stress is 1600 psi. If it has then a 1.3e like here, it's telling us that our reference modulus of elasticity, the one that we would use for the deflections, for deformations, not for stability, would be 1.3 times 10 to the 6 psi, pounds per square inch. So that's really one way of mentioning and referring to these glulams. Most often what we'll see is something like this, where again the 16F here on the left That's telling us what FBX is. It's 1600 psi, that's the 16. And then V is for visual grade, and 3 is the combination number that we're going to be using. Okay, we'll see in the examples, but really the difference in capacity has to do with the layups. For example, you may have special tension if it's a simply supported beam and you want more capacity at the bottom because you're going to have positive bending. This is the member in tension, so this is where you need your better lumber. You may have not as good lumber, and so that's the numbers that are here as you go up. And so, for example, 24F, that means that the reference would be 2400 psi. But if you look at visual grade, these two beams side by side, visual grade 4, that has larger capacity at the bottom and less on top, because the lumber that's being used on top is lower quality, lower capacity. And then visual grade 8, so 8 is the setup and how the layup is put together. You see that we have the same members top bottom, so same lumber. That means very specifically V4 would be one that would have an FBX positive, so the positive capacity would be 2400 psi, and on this case FBX negative is 1600 psi, and we'll see different reference values when we look to the tables. But 24F V8, both the positive and the negative bending reference values, they're both 2400 psi. Okay. So in terms of introductions, last few things, I do have here table 531 is referenced for the adjustment factors for glulam members. If you recall, for sawn lumber, we had tables 431 and 432 that were important. So for sawn lumber, all our adjustment factors and what factors we should use where, they're referenced in 432. Now what we're doing is glulam members. So we go to table 531, and that tells us which factors we should use where. The factors, they're very similar to what we had in sawn lumber. There is a new one, this volume factor. This replaces what we had before, which was our size factor in sawn lumber. That was the C sub F. And then there's many of them that only show up on very specific cases. For example, the curvature factor is only if you have curved members. The stress interaction factor, not an incision factor now, it only applies if you have tapered members. There's a shear reduction factor that only applies in very special cases. You can read those up in section 5310 and so forth. But the main ones that we'll use a lot of, which is this column stability factor, pretty similar, but we do have to look at table 531 to check if it applies and when. But when I mean it's pretty similar, I mean it's similar calculations to the sawn lumber. Sawn lumber cases. Okay, there is this volume factor, what I had just mentioned, the C sub V. It only shows up sometimes, so we'll look as we go through an example later. We'll look and read carefully when it does apply. But really, it's based on many tests that were done, and many tests that had reference member length, reference member depth, and reference member width. And then if it's Western species, that's, Douglas fir, and a lot of the timber that we use here in Oregon and the Northwest is Western species instead of Southern pine. If it is Western species, then there's a factor that shows up here, this exponent, and it's always 1/10. You see? This number, once we've computed all of these together, where L has specific length, that's our reference. Here's our reference width and our reference depth. So that means L reference is 21 feet, 12 inches, and 5 1/8 of an inch. Those are the numbers that I just highlighted. And then we actually have to go and check our members, the actual beam size. What is L? What is the length of the beam? And that's the length between supports. And what's B, what's D, and what's the length? And that's assuming here's our load. Okay? If it's Southern pine, it's 1/20, the factor. So the volume effect is less significant. So that just gives us an idea of what numbers we're going to get. All right, so that's it for the introduction. I'm going to store and save this video. That's about 11 minutes here. And then I'll give you the examples in the next video.